altitude, attitude, inertial. The Air Data Inertial Reference System, Adirs, provides temperature, airspeed, altitude, attitude, inertial, and aircraft position to the displays, flight management system, flight controls, engine controls, and other systems. Basically, the Adirs replaces the Air Data Computer and the IRS that are installed on earlier aircraft types. The Adirs is comprised of 3 Air Data and Inertial Reference Units, ADIRUs, a Control Display Unit, and many inputs and outputs. An ADIRU has 2 major features. They are Processing Air Data Information, ADR, and Processing Inertial Reference, IR, information. Each feature operates independent of the other, and a failure of one feature will not affect the other. Notice on this frame the outputs of each of these features. Specifically, the Adirs supplies data to the items shown here. The inertial reference, IR feature of the system must be initialized before flight by performing an alignment. It is possible to perform a full alignment or a fast alignment. Let's begin with a description of the system components. The Adirs control panel, Adirs CDU, is located on the left side of the overhead panel. It provides control over all 3 ADIRUs and also provides the ability to display the data from each ADIRU. To complete the alignment of the inertial reference portion of the Adirs, the present position of the aircraft must be entered by the crew. Although you may enter the present position on the Adirs CDU, it is normally entered on the MCDU. Note, the inertial feature of the Adirs is able to process magnetic headings only between 73 degrees north and 60 degrees south. This is because the magnetic variation is stored in the Adirs for only these areas. Operation outside these latitudes will cause the Adirs to produce true heading instead of magnetic heading. On this frame, we show the 4 types of sensors that provide air data and an angle of attack to the Adirs. All sensors are electrically heated to prevent ice buildup. The air data is converted from dynamic pitot and static barometric pressure information to digital data by 8 Air Data Modules, ADMs. The last component we'll identify is the switching panel that allows the pilot the ability to switch to ADR3 or IRU3 for instrument displays in case of failure of ADIRU 1 or 2. On the pedestal switching panel, the ATT heading and air data switches are usually in the norm position. With the ATT heading switch in norm, ADIRU 1 supplies data to PFD1, ND1, DDRMI, and VOR-DME, and ADIRU 2 supplies data to PFD2 and ND2. With the ATT heading switch in the Captain 3 or First Officer 3 position, the selected pilot's attitude and heading displays receive data from the ADIRU 3. This is the inertial reference portion. With the air data switch in the Captain 3 or First Officer 3 position, the selected pilot's airspeed and altitude data is provided from ADIRU 3. This is the air data reference portion. ADIRU 1 is supplied by the captain's probes. ADIRU 2 is supplied by the first officer's probes. ADIRU 3 is supplied by the standby probes and the captain's total air temperature. The ADMs convert dynamic air pressure from the 3 pitot probes to a digital format. The standby pitot probe also provides raw dynamic pressure to the standby airspeed indicator or integrated standby instrument system, ISIS. The ADMs convert barometric air pressure from the 6 static ports to a digital format. The standby static ports also provide barometric pressure to the standby airspeed indicator and the standby altimeter, or the Integrated Standby Instrument System, ISIS. Each Adirs receives data from the three respective angle of attack AOA vanes. Adirs 1 and 3 receive total air temperature data from the captain's TAT probe, while Adirs 2 receives total air temperature data from the first officer's TAT probe. This is the Adirs CDU. It has the controls and indicators for the Adirs. Starting at the top is the display for the CDU. Just below the display are the data selector knob and the system selector knob. The 6-position data selector knob allows the pilot to select which inertial reference data is to be displayed. The 4-position sys selector knob is used to turn off or select which Adirs system data will be displayed as selected by the data selector knob. On this frame, assume the Adirs is operating normally and has been aligned. You can click the labeled positions on each knob to view the display and see a pop-up description. The keyboard is located just right of the system selector knob. It has letter keys, number keys, a clear key, and an enter key. The keyboard may be used to enter present position during the alignment, or to manually enter heading to the system when operating in the ATT mode, since normal inertial reference heading is inoperative in ATT mode. However, you should know that inputs are normally made to the MCDU and not through this keyboard. The on-bat light should normally be extinguished when normal power is on the aircraft. The light comes on briefly during the beginning of the alignment process to indicate a startup test. Note, the on-bat light does not illuminate during the initiation of a fast realignment. The on-bat light also illuminates if one or more inertial reference unit is on battery power. If the aircraft is on the ground when the on-bat light is illuminated, an external horn sounds, and the Adirs and AVNCS light illuminate blue on the external power panel. There is one IR mode selector for each Adirs. Each switch has 3 positions. In the off position, the associated Adirs is not powered. The nav position is the normal position for flight operations. The ATT position is selected for abnormal conditions when the nav mode has failed. During pre-flight, the pilot will select all 3 IR switches to nav. When the IR switch is moved from off to nav, the associated Adirs starts to initialize and align. Crew input of aircraft present position is required for the alignment to complete. You will not normally select the ATT position. The ATT mode provides reduced operation and is only selected for abnormal conditions. Additionally, once the ATT mode is selected, the nav mode cannot operate for the associated Adirs until an alignment is performed on the ground. The ATT mode provides attitude and heading data and cannot determine aircraft position. If ATT is selected as the sole Adirs heading source, the crew must check heading with a standby compass periodically and re-input the corrected heading when necessary. The white align light comes on steady during the alignment process. It should go out when the alignment is complete. A flashing align light indicates the alignment will not complete. More on that later. The amber fault light illuminates steady if the inertial reference feature of the associated Adirs has failed. The fault light flashes if it is possible to recover the ATT and heading information by selecting the ATT mode. Okay, let's demonstrate the alignment. Assume the aircraft is normally powered. You will click the nav label of each IR selector to move the switches from off to nav, and notice the align light illuminates for each Adirs. The on-bat light comes on briefly during the startup test. You must input the present position within 10 minutes or the align lights will flash. The align lights will also flash if there is an IR alignment fault or if the difference between the position at the last shutdown and the entered present position exceeds 1 degree of latitude or longitude. In some cases, the position may have to be entered more than once to get the Adirs to accept the input. For the alignment to complete, you must enter the aircraft present position. This entry is usually performed on the MCDU. With all 3 IR switches in nav, the position input from the FMS MCDU will be delivered to all 3 Adirs at once. The airplane must not move until alignment is complete. When the alignment is complete, the align lights go out and the attitude and heading displays appear on the PFD and ND. The Adirs is now operating to provide attitude, heading, and position information. Other data provided by the Adirs is airspeed, ground speed, barometric altitude. The air data reference switches are push-button switches with momentary action. Normally, these 3 switches are on and their lights are out. Selecting an ADR switch to off will disconnect the air data output from the associated Adirs. With the ADR operating, the illuminated amber fault light indicates that a fault is detected in the air data reference portion of the associated Adirs. An ECAM caution activates when a fault light comes on. This completes our description of the Adirs. Now let's answer some questions.